In this video, you're going to learn about rotations. You might remember from middle school or even elementary school that to rotate something means to turn it. So when we're talking rotations, we're really talking about taking a figure and turning it. Just like we have notation to represent translations and reflections, we also have some notation to represent rotations. The notation or the abbreviations we're going to use for a rotation is the capital or uppercase R. Now it's important to note that this is a capital or an uppercase R to represent a rotation, whereas the lowercase r, remember, represents a reflection, and the capital T, of course, stands for translation. So that can be a little confusing for students at times. Make sure, again, you know that the capital R or the uppercase R stands for a rotation. The lowercase r stands for a reflection. Getting back to our rotations, we're going to use that uppercase R to represent a rotation. And to describe a rotation, we really need to talk about or consider two things. The first thing that we need to consider is where the center of that rotation will be. The center is going to be a fixed point around which everybody else will turn. The other thing that we need to take into consideration is the number of degrees that we will turn the shape. So when we describe a rotation, we're always going to name the center. And again, that's the fixed point about which everyone else will spin, and the number of degrees. And that tells you how far you're going to turn it. When describing the center, if the center is not named, we're going to know that the center is the origin. So again, if the center is not named, use the origin. We need to talk a little bit about direction because that's important. When we turn something in the counterclockwise direction, in other words, the opposite of the way the clock spins, you might think about running around a track as typically done in a counterclockwise direction, or cars around a racetrack typically done in a counterclockwise direction. A counterclockwise direction is always going to be represented by a positive number of degrees. And this can be a little counterintuitive for some students at times. So if we were turning something, say, positive 120 degrees or positive 180 degrees, those turns would be done in the counterclockwise direction. Negative number of degrees, on the other hand, would be a clockwise turn. So in this case, if we wanted to spin something or turn something negative 60 degrees or even negative 80 degrees, that would be a turn in the clockwise direction. Well, we're working in the coordinate plane. We're always going to perform rotations in multiples of 90. And that's because it's easy to turn in multiples of 90 because our coordinate axes is divided up or split up into 4 quadrants. And if there's 360 degrees in an entire turn, then when we divide that equally by 4, they end up being in increments of 90. So let's go and let's do that right now. Let's go ahead and let's actually perform some rotations. So in this example, it says given point P with coordinates 4, -3, they want us to go ahead then and find point P prime, point P double prime, and point P triple prime. I'm going to go ahead and I'm going to begin by plotting point P on my graph. You should go ahead and plot point P on your graph also. Remember that the capital R stands for rotate. They're telling us the center of our rotation is going to be the origin, the point 0, 0. And they're telling us the number of degrees that they want us to turn this figure or this object is 180. If I were to rotate a triangle or a quadrilateral or some other geometric shape, I would perform that transformation the same way I perform any other transformation in one point at a time. So once you can rotate points, you'll be able to apply that idea to rotate entire geometric shapes. But we're going to go ahead and we're going to start just by rotating points. So the center, 0, 0, is going to stay put, and everybody else is going to spin or to turn around that center. In this case, I'm going to turn 180 degrees. So 180 degrees would be half of the way around the circle, or in other words, two turnings of 90 degrees each. So I'm going to go ahead and I'm going to take my point P and I'm going to turn it 90. And again, I'm leaving that origin put. And then I'm going to turn it another 90. And when I turn that 180 degrees, notice that my point P now is 4 units to the left of the origin and 3 units up. So the name or the coordinates of that point that's 4 units to the left of the origin and 3 units up is the point -4, 3. So point P prime now has coordinates -4, 3. So again, everybody else is going to stay put. The origin is going to stay put. Everybody else is going to turn around that origin. And then once that turn is complete, you'll write down the new coordinates. All right, I'm going to go ahead and set that graph back to where it started. I'm going to erase the work that I did for point P prime, and I'm going to go on to the next one. Letter B says find the coordinates of P double prime. And this is important to realize this is going to be the image of point P. So it's not going to be point P prime that we're rotating. It's going to be this original point, point P, that we want to go ahead and rotate. But this time we want to rotate using the origin as our center. But now we're only going to rotate 90 degrees. And because this is a positive 90 degrees, we know we're going to go counterclockwise. Positive 90 degrees would be 1/4 of a complete turn. So I'm going to again leave the center where it's at, but I'm going to go only 90 degrees. I'm going to go 1/4 of a complete turn. Notice now that my x-axis has now become my y-axis. My y-axis has become my x-axis. But my point P prime is going to be the point that is 3 units to the right of the origin and 4 units up. So the coordinates of the point that's 3 units to the right of the origin and 4 units up is the point with coordinates 3, 4. So the coordinates of P double prime, therefore, would be 3, 4. All right, to do the last one, I'm going to send everybody back to where they came from. I'm going to erase on my graph. This time I want to find point P triple prime, which is also the image of point P. So again, it's important to notice here that point P is my pre-image, point P is my starting point. I'm not going to use P prime or P double prime, but I'm going to go right back to that original point P. This time I want to rotate again using the origin as the center, but I want to go a positive 270 degrees. So 270 degrees would be 3/4 of a complete circle. So in other words, I want to turn 90 degrees 3 times. So I'm going to start with my point P where it's at. All right, so to turn 270 degrees, I'm going to go 3 sets of 90. counterclockwise. So there's 90, there's 180, there's 270, and now I'm going to record where point P ended up. So point P ended up 3 units to the left of the origin, 4 units down, and the name of the point that lies 3 units to the left of the origin and 4 units down, that point has coordinates 3, -4, and in this case, that's going to be P triple prime. So the coordinates of P triple prime would be -3, -4. All right, that's about all I have for you today, folks. I want you to see if you can apply what you've learned to the Check Your Understanding questions on the next page. And next time we meet, we'll get together and we'll talk about key ideas. As always, thanks for your time and attention.